Hello students, in my last video I have discussed about Z transform, basic formulas and basic definition. Now let us understand one rule which is called shifting rule. What is this shifting rule? If Z transform of Un is uz, then Z transform of Un minus k is z to the power minus k uz. Same way Z transform of Un plus k is z to the power k, and in bracket uz minus summation r is equal to 0 to k minus 1 ur z to the power minus r. Now for example, if I want to apply this on this un plus 1. So first z to the power 1 will come. Then in the bracket uz will come. And this summation when I open, I will put r is equal to 0. So u0 only will come. Same way when I will do z n plus un plus 2. So z square will come out. And inside you will start from uz minus u0 minus un by z. Same way n plus 3, z cube will come out, then uz will come out, then u0, then u1 by z, and then u2 by z square. So this is how we apply the shifting property. Let us see one question. Show that z transform of 1 upon n factorial is e to the power 1 by z. So what is z transform of un? Z transform of un is equal to uz. This we all know, right? So now when, and this is equal to summation un z to the power minus n is equal to 0 to infinity, which is a basic definition, right? So now z transform of 1 upon n factorial is equal to uz summation, not uz, you write down the definition, you apply the basic definition. So it is summation n is equal to 0 to infinity 1 upon n factorial z to the power minus n. Okay, so this will be equal to, if I start putting the value, so n is equal to 0 if I put 1, plus 1 if I am putting z to the power minus 1, plus 1 upon 2 factorial z to the power minus 2, dash dash dash. And this is what? This is a simple series of e to the power 1 by z. So first part is proved. Now they are asking find the z transform of 1 upon n plus 1, right? So n plus 1 when I am doing, I already have the result for z to the power n 1 by n factorial is equal to e by 1 by z. Okay. Now when I am doing this, I'll apply the shifting property. If I apply the shifting property, this will become k, z to the power k, and k here is 1, so that to the power 1 in bracket uz minus u0. Now what is u0? The un value is 1 upon n factorial. So u0 value will be 1 upon 0 factorial, which is equal to 1, right? So what I'll do, I'll substitute here. So this will be z uz minus 1. Answer. Same way when I am asking you z transform of 1 upon n plus 2. This is z square uz minus u0 minus u1 by z. Okay. Now un value is 1 upon n factorial. So 0 I am clear. If I do 1, so u1 is equal to 1 upon 1 factorial, which is 1 only. So this become 1 by z. Okay. So this value will be z square uz, u0 is 1 and u1 z, right? So here what I'll do, u1 by z. So u1 value will be what? 1 you are putting na. So minus 1 by z. So this is how you can find out the values. Now look at the next question. If un is equal to this, show that z transform of un is this. Simple. Un is this. So z transform of un is what? Summation n is equal to 0 to infinity un z to the power minus n. Substitute the value. So n is equal to 0 to infinity. Un value is what? Un value is 1 by 2 to the power n, right? And z to the power minus n. So this is summation 2 to the power 2 and z to the power minus n. Okay. Now I got this simple expression where n is equal to 0 to infinity. If you open this, what will happen? 0 when you are putting, it is 1. Then 1 by 2z to the power n. And I am putting 1. So 1. Right? And it is negative also, so minus will come here. Okay, wait, I'll rewrite this. First put n is equal to 0. N is equal to 0 means 1. Plus, now if you put n is equal to 1, so 2z to the power minus 1 plus 2z to the power minus 2 plus 2z to the power minus 3. So 1 plus 1 upon 2z plus 1 upon 2z square plus 1 upon 2z cube. Done. Right? Let's see the next one. Now show that z transform of un is equal to uz. Show that z transform of nun is this. So let me start with the right hand side. So minus z d by dz of uz is what? Uz is basically summation of, it is summation of un. So uz is un, okay, z to the power minus n. Right? Now this was actually uz. So we have just replaced this uz by its definition. So minus z. Now if you differentiate summation, I can't come out. So this will become minus n. Okay. And z to the power minus n minus 1. Now next step what I am doing, this n and z are coming together. N is equal to 0 to infinity. So n I cannot take out. Un also you cannot take out. Okay. But here z to the power minus n minus 1 is there. So can I write it like this? Minus z un minus n z to the power minus n z to the power minus 1. Okay, this is equal to, we have to figure out, and 1 minus z is outside. So if you see this and this, they both will get cancelled. So what is left? Minus n un z to the power minus n. And now summation is also there. Once you reach to this point, what is this? This is the z transform of nun. But here one mistake, I got this minus sign. This minus sign should be absorbed somewhere. Yes, minus sign is going. I forgot to cancel it. Right? So this is how you have to do the question. Just understand, it will be having a very small concept in it. Right? So now come to the initial and final value theorem. Now what is the initial value theorem? Z transform of un is equal to uz. Okay. Then limit uz is equal to u0 and limit z tends to infinity. Okay. So what is the initial value theorem? Initial value theorem states that if z transform of un is uz, then limit uz is equal to u0. So let us start with this. Now when I am saying uz, okay, means I am talking about z transform of un. And this is summation un z to the power minus n is equal to, now what I will do in the next step, I wrote like this. Now this is by definition is equal to uz. Correct? Now open the summation. So uz is equal to, n is equal to 0. So when you put 0, so z to the power 0 is 1, gone. Plus 1, so u1 z to the power minus 1 plus u2 z to the power minus 2. Correct? Now take limit z tend to infinity on both the side. So limit z tends to infinity uz is equal to u0 and u1 upon z. When you put z is equal to infinity, 1 by z becomes 0. So you are left with only u0 and your initial value theorem is done. Now let us come to the final value theorem. Now final value theorem is little lengthy and more important. What does it says that if z transform of un is equal to uz, then limit z tends to 1, z minus 1 uz is equal to limit n tends to infinity un. Okay, so now let us start solving this. Now we know what is the z transform of un plus 1. Z transform of n plus 1 will be equal to z uz minus u0. And z transform of un is what? It is uz. Correct? Now subtract these two. Z transform of un plus 1 minus un is equal to z minus 1. Is z here from z u0 will come. See, I'll open the bracket. So the first term is z uz minus z u0 and minus uz, because we are subtracting these two equations. So z transform of un plus 1 minus un is equal to, look at these two, uz z minus 1 minus 240. Correct? Now what happened? Now I want, sorry, why I am writing 240? It is z u0. So z u0. Okay, let me check it again. These two I have combined and z u0. Okay. Now what I will be doing, I will take a limit in this. And this side I will apply the definition of Z transform. When I apply the definition of Z transform, what I will get, Z transform of anything is summation n is equal to 0 to infinity un plus 1 minus un. Okay, un plus 1 minus un and z to the power minus n is equal to uz z minus 1 minus z of u0. So now take limit z tends to 1. So when you take limit z tends to 1. So summation n is equal to 0 to infinity and un plus 1 minus un and z to the power minus 1 is also same thing. So when I put n is equal to 1 here, limit z tends to 1 here. So 1 to the power anything is 1 only. So that is gone. Here limit z tends to 1 uz z minus 1, and here when I put z is equal to 1, I am left with only u0. Correct? Now once you reach to this point, what you have to do, you have to just open the summation. Okay, just open the summation and here already their limit is applied. Now limit z tends to infinity 1 is already there. Now I have to open this. If I put n is equal to 0, so u1 minus u0. Okay, then n is equal to 1. So u2 minus u1. Right? Like this I can open it. Then plus dash dash dash, and suppose you have the last number is um plus 1 minus um. Okay, now see here you need to understand this thing. I have taken z tends to 1 and nowhere it is required actually, because once you have put the value it is not required. Now this limit I have opened. Now I have to apply the limit here. Okay, and we have to also take care ki what is this summation equal to. This summation is equal to this factor. Correct? Now all of you pay attention here. Okay, so before opening this thing, just have a look like this. Now we are working on this thing. So limit z tends to 1 uz z minus 1 means this side is equal to u0 plus, here already limit is applied, so it is not required now, summation un plus 1 minus un. N is equal to 0 to infinity. Right? So limit z tends to 1 uz z minus 1 is equal to u0 plus, put n is equal to 0. So u1 minus u0 plus u2 minus u1. Like this it will go up to um plus 1 minus um. Right? Like this I can write कि I have to open the bracket. Okay, and it is still infinity, so I restricted it to um, but when I am restricting it to um, here I should put limit m tends to infinity, because in actual it is going till infinity, right? So I have limit z tends to 1 z minus 1 is equal to u0 plus limit m tends to infinity, and inside the bracket if you observe, this first term is getting cancelled by this, but second term this will be preserved because before this there is nothing, so minus u0. And same way if I keep on going, the first number will get cancelled, but in the last one it is getting cancelled by the next number. In the last one I won't get that, so last term will be plus plus 1, correct? So now I got this expression. Now this u0 and this u0 will get cancelled. So limit z tends to 1 z minus 1 is equal to limit m tends to infinity. Okay, and here it is m plus 1 and minus u0 if you take out. So what is left there? So I am left with m plus 1. Now tell me one thing, if m tends to infinity, m plus 1, whatever is value, okay, then it should be noted that as m tends to infinity, okay, and m plus 1 also tends to infinity. When m is tending infinity, m plus 1 is also tending infinity definitely. Hence RHS is equivalent to limit m plus 1 to the infinity m plus 1. So in place of m I can write limit m plus 1 tends to infinity. Correct? Now what will happen after this? So we got a relation, we can represent this m plus 1 by some n. So our net result is limit z tends to 1 z minus 1 is equal to limit n tends to infinity un. Okay, so this is a proof of final value theorem. I hope you understood it. In my next video I will do inverse of z transform and difference equation. Thank you.